Hey everybody, I'm back again. This is Chris with Overclockers Club. It's Power Supply Day. I'll be taking a look at the BXM 850 and the GEX 850. They are both 850 watt power supplies, but we'll go over the two and see what the differences are and what the similarities are. So, sort of a quick glance, you can see the differences are pretty obvious. The BXM has this orange top plate where the GEX does not. But the big difference you may have noticed is that the GEX is fully modular, which means every single cable that you will be using, you will be connecting to this side panel here. And the BXM is also modular, but it is not fully modular. While you do have places to connect cables, you have a set of cables here that are permanently attached. So these are the cables that are permanently connected, and they're the ones you're going to use all the time anyway. You have to have your main 24-pin power connector for your motherboard. You're going to need that no matter what motherboard you use. There's an extra, let's see this one here. This has got your CPU power, and you may or may not use all of these, but you're going to need this also. So it's permanently attached. You're going to use it no matter what. Now I do question this one here. This is a PCIe cable or a connector. This is like for a graphics card, and usually your graphics cards, a lot of them, most of them, will have two sets of connectors. It either uses two 6-pin connectors, or it uses an 8 and a 6, or depending upon the graphics card you've got. So I'm a little surprised that there's just one 6+2 connector here rather than the branch sort of like this one to have an additional connector. But I guess that doesn't really matter in the big picture. So what I need to do is now compare what cables are included between these two. Here's the list that shows what cables are included. You can see on the top there are the three that are permanently attached to the BXM 850. Of course, that's the first one we're looking at here. You look to the right, I've got the 850W column highlighted in yellow because that's the power supply we have. It also covers the 700W, but you can see the number of cables that are included. Again, the top three there are the ones that are permanently attached. The bottom four, it also shows the length of each cable as well as the connectors that are on each cable. You can pause this for a moment if you want to absorb what's going on with the cables, and then we'll move on to the GEX. And here is the GEX 850. Again, I highlighted the 850 on the far right. This chart also covers the 650 and the 750, so you can see the cables that are included, as well as the cable lengths and what connectors are on each cable. And of course, you can pause this for a moment while you take a look and see that this has all of the right cables that you need in the right quantities and the right connectors. And now we'll talk about efficiency. So I'm looking at the 115 volt curve. If you look at the two, the BXM is on top, the GEX is the bottom one. You can see the efficiency is very similar at 50%. So the BXM is right around 87 and the GEX is just a tad over 90. So there's not a lot of difference. What that means is energy going in versus energy going out. So the more efficient, the less heat you're going to generate for a given watt of usage. So basically, you're taking the wattage of all of your components and you're adding that together, and you'll get a total. Say everything adds up to 500 watts. So you wouldn't want to pick a 500 watt power supply because then you would be saturating it at 100% load all of the time when you're running your system with everything going, assuming you're overclocking and you're doing a lot of gaming. But typically your system is not going to be running at 100% with all of your components using the maximum amount of wattage. So if you're using 500 watts, or if your system is all of your components added together is 500, you wouldn't pick a 1000 watt power supply. You would probably pick something closer to the 750 to 800 because at 50% you're going to be using 200, maybe only 250 watts. And when your system is idle or you're just doing some internet browsing, stuff like that, you may use 100 watts or even less. So the takeaway from all this is bigger is not necessarily better. You might think it's cool to have a 1000 watt or a 1200 watt power supply, and there's nothing wrong with that, but it's just overkill, and you probably won't ever really use all that extra wattage, and you won't operate in that 50%
maximum efficiency range. So you would be better off getting more bang for your buck spending your money on a nicer monitor or a nicer graphics card, because the additional horsepower on your power supply probably won't ever really get used. And a lot of manufacturer websites have an online power supply calculator. So you put in all of your components and it will basically give you a listing of the power supplies that it recommends based on your input. Next is the specification list for the BXM. Again, the 700 and the 850 are shown, but I have the 850 highlighted in yellow so you can sort of look at these specifications. You can pause it again if you'd like for a moment, and then we'll move on to the GEX. Again, this one shows the 650, 750, and the 850, and I have the 850 highlighted in yellow so you can focus on that. And here's a quick look at the specs of my test system.
All right, now I'm ready to do some thermal testing. I moved things around a little bit so that the exhaust coming out of the CPU cooler and the exhaust coming out of the GPU all go off to the left and they don't get sucked into the intake of the power supply. I also took the screws out of this cover so that I can look down in there with the thermal camera and see if anything unusual shows up, which I doubt, but you never know. Okay, so the motherboard here is a Z390 Strix from ASUS. I'm using a 9900K CPU. I've got it cranked up for the overclock of 4.9 gigahertz. It will actually go a little higher, but there were some stability issues and some blue screens, so I just backed it down to 4.9 gigahertz, so that seems to work well. All right, so let me crank up the load on the GPU and the CPU and sort of simulate what a workload would be on this power supply. Now, this isn't really going to max out the power supply by any means, but it will at least give you a general idea. And another difference here between the two power supplies is the fan. On this one is 135 millimeter, whereas this one is a 120. And the RPM range, this one actually is right around full speed of 1800 RPMs, and this one is just a little under 1800 RPMs. But probably the biggest difference is this is a 0 RPM fan, which means when the load is low and the system is cool, this will actually stop the fan. Whereas this one, the fan runs all the time. Even though it does slow down when it's cooler, it will run all the time. Now, for anyone who has a question about fan noise, I've got my decibel meter here. And actually, the fans here on my CPU cooler are much louder at a full RPM or full load than the fan is here on the power supply, and I'll show you. So, and then we'll compare that to so there's really not much in the way of sound coming from this, even when the fan is running at a decent speed. All right, so we got the thermal camera out here. It's about 68 degrees Fahrenheit, which is about 20 degrees Celsius in the room. We'll maintain that temperature. Looking at the exhaust side of the CPU cooler there, you can see we got a little bit of heat coming out, a little bit on the bottom of the motherboard, around the base of the CPU socket, and then the graphics card. If I can get it focused, it's pushing out a little bit of heat also. And then looking at the power supply itself, and let's see, the exhaust is right here, so we'll look at the back side where the exhaust is coming out. I can get my camera focused. So we're real close to 35 degrees, yeah, just a hair over 35 Celsius. That's the exhaust temperature of the air coming out. And then I'll take this cover off so that we can look down in there a little more clearly. And I don't see anything really unusual there. The temperatures of the components don't look out of the ordinary. Now I do not recommend this next step here. I actually took the cover off the power supply, and it's a little tricky because the manufacturer does not want the average person taking the cover off of their power supply. So I do not recommend doing this at home. That's why I'm doing it, so you don't have to if you want to see what's going on inside there. And there's a little screw on the side that you have to take off, and you of course void the warranty by removing the little security sticker on that. So again, I'm doing this so you don't have to do that if you want to see what's going on inside the power supply. So really there are, you got your transformers, your capacitors, voltage regulator, all that good stuff down in there. And if you're not into electronics, none of this really means anything to you. And if you are, you know exactly what you're looking at. Now looking at the wiring groups here for the GEX, one thing I like that I notice is we have black wiring that goes all the way up into every single one of the plugs, regardless of the wiring group. And that's on the GEX. Whereas on the BXM, one thing I don't like, the only thing I would complain about is we have these yellow wires here on the main section that goes to supply power to your CPU, and that is one of the permanent sets of wiring that is attached to the PSU. But here on the main 24 pin, you've got this whole rainbow of colors. They sort of stop short right here. They terminate, put their heat shrink on there, and then we have all these wires exposed. Now, some people maybe wouldn't care about that. Back in the days of computer cases being all solid with no way to see the components, who really cared what color the wires are? But that might be something to consider, especially if you're building a system and you're trying to stay with a particular theme, or you want your wiring to look a little more stealthy and not draw attention to it with the bright colors there. As far as dimensions go, and both of these power supplies, the GEX and the BXM, are the same physical dimensions, and we've got 150 by 160 by, and I believe this measurement here is about 87 millimeters tall. And there's also a little tag back here. It's pushed out of the way. It peels right off. But anyway, it talks about how don't be surprised if the fan doesn't run. And it did when I first plugged it in, just very briefly. But again, it's a 0 RPM fan, so unless there's a really big load on it, you probably won't see it run. But we're going to test that here in just a moment when I fire the stress test up here. Alright, so the stress test is rolling, and we'll see how long it takes for enough of a load to cause the fan to fire up. And we are at about getting close to 3 minutes, and still just a little bit of warmth over here on one side. Everywhere else is still cool and no fan activity. I'm surprised. I really figured the fan would have kicked on by now. And we just passed the 3-minute mark. And there's the 4-minute mark. And still the same thing. It's a little warmer over here on this side, but still no fan activity. Alright, well, I'm 6 minutes into it. Still no fan activity. You can see where the warmth is over here on this area. And then we look at the exhaust side, and we can definitely see a little bit of heat in there. But the fan has not kicked on yet, so I'm impressed. Can't really do much with my decibel meter if the fan isn't running. And we're coming up on 8 minutes. Still no fan movement. I don't see anything horrible as far as temperature-wise. It still is warm in that one little area. And look at the back again. You can see some of the components there through the mesh on the back. And the motherboard, you can see the heat coming off of the CPU cooler there. And there's the base of the socket there for the CPU, so it's plenty warm down there. And then the exhaust temperature of the GPU. So, like I said, I'm impressed. Wow, it's been, let's see, 10 minutes and 30 seconds, and still the fan is not kicked on. You can definitely feel a little bit of warmth there. I really would have figured this thing would have kicked on, or at least started to cycle on and off after a couple of minutes, but so far nothing. And now that I think of it, maybe since the fan is facing up, we have convection where the heat can rise right out of the vent. Fresh air can be pulled in from the side here. So maybe one of the reasons the fan isn't coming on is because of the orientation. So I might have to redo this test with let everything cool off back to ambient, and then try it again with the cooler flipped over with the fan facing down and see if there's a difference. Alright, so I've got the stress test started again. I've got the power supply flipped over. So now I'm going to watch the fan, and it's a little hard to see, but I can see it. We'll see how long it takes to come on. Well, we're about 7 minutes into this one with the power supply flipped over, and I still have no fan movement. You can see there is some heat buildup here on the top surface of the case, which is not a surprise. You can feel it. It's nice and warm. And then looking at the exhaust side, you can sort of see some of the components through the mesh a little bit where they're a little warm also. But no fan. Okay, about 11 minutes in, the fan just started to cycle. It comes on for a few seconds and then turns off. So perhaps having the power supply flipped over with the fan facing down causes just enough heat to build up inside that we get the fan to cycle. I never did. I let it run 15 minutes before with the fan facing up, and the fan never did come on, so sort of answers that question. And as with the other power supply, do not do this at home. Do not take the cover off yourself. There are a lot of dangerous components in there when they're exposed. A lot of voltages you don't want to be around. So I'll take the cover off so you can see what's in there, and you don't have to do it. So we have the same sort of mixture of capacitors, transformers, rectifiers, voltage regulators, coils, all kinds of good stuff in there to give you the proper output voltages that you need for a good power supply. And looking at the business ends here of the two power supplies up close. Of course, this is the BXM and this is the GEX. But you can see it looks like there are more connectors on this one than there are this one. But you have to remember, we have some permanently attached cables here that take up some space here. So if you start counting connections, actually there's one more on this one than there is here. But that's something you need to compare and see which one of the two would cover your usage scenario. Pricing, really, this one is like $99 and the GEX is like $109, so there's only like $10 separating the two, which is not much. And of course you have to look at pricing on Amazon and Newegg because they seem to change and fluctuate a fair amount. But if I were going to have to pick between the two, it would really be tough. They're both good power supplies. They seem to get the job done. If you want the ultimate and quiet, you would probably go with this one, although when these things are buried deep in your case with the covers on and all, you really can't hear the power supply much anyway. So it would be sort of a tough choice, although the deciding factor for me personally would be fully modular. I do like that, the ability to use only the cables that I need. And the only other thing I didn't care for so much on this one was the exposed colors there. And I know you can sort of cover that stuff up, but I guess if I'm going to pay an extra $10, I would probably go with the GEX. But again, they're both going to get the job done. All right, so before we wrap this up, the other differences I would highlight are we've got a 3-year warranty on the BXM, we've got a 5-year warranty on the GEX. And again, the GX is slightly more efficient. It is fully modular. So I would give the BXM probably the silver award, and I would give the GEX the gold award. And I'm basing a lot of that on the fact that the pricing is so similar between these two. So anyway, this is Chris with Overclockers Club. Any questions, comments, post them down below and I'll try to answer them as best I can. Thanks for watching. Don't forget to subscribe.